Good afternoon. This is Jack Himes at the Pennsylvania Recycling Market Center, and we're getting ready to start the Technology Tuesdays webinar series, and that is sponsored by the Recycling Market Center. Today we'll have two speakers and a brief introduction by myself of the Recycling Market Center. After each speaker is done, if there are questions that come in, and there should be a question area on your screen where you can type in any questions that you may have for the speakers. And if there's time, we may answer a few questions after the first speaker is done. It was established in 2004 as a nonprofit organization. We have 5 full-time employees, and we're basically located at the Penn State University, Harrisburg, Pennsylvania campus with a satellite office in Pittsburgh. We're governed by a 9-member board of directors plus 4 ex officio members. The employees at the Recycling Market Center include Bob Bailone, our CEO, Melanie Morrison, who keeps things running smoothly, Wayne Bowen, who's the technical expert behind the screen on today's presentation, myself, and Pete Previte. Pete Previte is located in our Pittsburgh office. This is the first Technology Tuesday webinar, and the topic is Innovation in Optical Sorting Technologies. The next Technology Tuesday webinar will be on December 11th, and the title for that one is Alternatives to Disposal of Gypsum Wallboard Waste. The Pennsylvania Recycling Market Center is proud to announce the start of the Technology Tuesday webinar series. These webinars will highlight various types of equipment used to sort and/or process materials that have been collected for recycling. Each session will give an overview of how this equipment works and the benefits that it provides in producing recycled material feedstocks with less contamination and potentially higher value. When possible, users of such equipment or techniques will be invited to discuss how this equipment or process has helped improve their recycling efforts. Today's webinar on advanced conveyor and optical sortation technologies will include 2 speakers. The first speaker will be Felix Hottenstein, Sales Director of MSS Incorporated. The second speaker is Matt Kugel, who uses equipment like this, and Matt is the Chief Operating Officer of Kugel's Recycling in Hanover, Pennsylvania. Our first speaker, Felix Hottenstein, in 1993 received a master's degree in material science engineering from the Federal Polytechnical Institute in Zurich, Switzerland. Between 1994 and 98, he worked as project leader and department head at EMPA and PEAK, 2 licensed materials testing institutes in Switzerland. Since 1999, Felix has been sales director for MSS Incorporated division of the CP Group of companies, a manufacturer or materials handling and sorting equipment for the recycling and waste management industry, where he specializes in all projects that include optical sorting. So now we'll turn it over to Felix.
Well, Jack and Wayne, thank you so much for the introduction and the opportunity for me to present our optical sorting technology to a wider audience. I hope everybody can hear me and see the screen on your webinar. I'm going to talk mostly about our optical sorting technology, but Jack also asked me to maybe go through a few other mechanical sorting technologies first, some of them that you might see in a MRF or equivalent facilities. The largest company of the manufacturing branch of the CP group our group of companies is CP Manufacturing. They design and build the complete turnkey processing and sorting systems, like a complete single stream MRF or a municipal solid waste handling facility. The second division is Kraus Manufacturing, which specializes in equipment to process and sort construction demolition waste. Then there is MSS, the company I work for. We specialize in the optical sorting technology, which you'll hear quite a bit more in a little while. The fourth company is IPS Balers, which manufactures a complete line of balers from the small vertical ones all the way to the large 2-ram and single-ram balers. The fifth company on the list is Advanced MRFs, which specializes and is our division for controls, system engineering, and system optimization software and hardware. So what I'll be covering on the equipment that is not optical sorters, which Jack had asked me to do, what we would call maybe the conventional MRF separation equipment, mostly pretty much all mechanical separation equipment. I'll show you some examples of sizing equipment like trommels and disc screens, some mechanical disc screens where we can separate and sort certain types of materials, such as OCC, newspaper, mixed paper, as well as breaking and screening out glass. I'll show you some examples of air classification equipment, for example, when we sort small fiber from broken glass or single sheet pieces of fiber from containers. And then I'll briefly touch on the metal separation where we use magnets and eddy current separators. The optical sorting equipment normally follows after any of these type of mechanical sorting equipment as a secondary step or fine-tune step or a polishing step, if you will. And so we'll cover these more traditional or conventional separation equipment real quickly first, and then we'll go into the optical sorter. So on the sizing equipment, as I mentioned, we use trommels or disc screens. It depends on the application. For example, in the upper left, you see a picture of a trommel that screens out fines from a broken glass stream. We use them with much larger dimensions for municipal solid waste and commercial and industrial wastes that are quite a bit dirtier streams. So at the bottom you see two large trommels in parallel screening out, for example, a 2-inch minus fraction in the first segment of the trommel and maybe a minus 8-inch fraction in the second segment of the trommel. On the right side you see a sizing screen for large cardboard, which works very well using these mechanical disc screens. You see elliptical discs that are mounted to shafts, and anything that is larger to probably about maybe an 11 by 17 piece of cardboard will kind of dance around and jump around and move over the top, while anything that is smaller falls through. So these is the kind of sizing equipment or mechanical sizing equipment that we use in our processing facilities. Again, different technology, trommel versus disc screens, depending on the application. Some more pictures of other types of disc screens. Again, on the left, two in parallel that sort OCC cardboard from a single stream input material. You have at the bottom left, we have a glass breaker screen in pretty much all single stream facilities that we put in, and I hope that most of you know what single stream material is and looks like. The requirement is that we try to break the glass as early as possible in the process, so the glass and the fines that are generated with it can be removed from the stream as soon as possible in order to not wear out the equipment downstream too much. So another type of breaking and sizing screen to remove glass. The two screens on the right side are screens that we use to sort two-dimensional from three-dimensional material. So in a MRF, that would be normally newspaper from containers. Some of them in larger volume facility or larger throughput facilities, we use multiple ones in series. So on a first step, we would probably just sort out large pieces of newspaper, which is the newspaper screen that you see on the upper right. And then as the material gets a little dirtier, a little more mixed paper, we use our specialized mixed paper screen to separate more fiber from the containers as we go down the line. In addition to the mechanical screens, we use air classification equipment for different applications. On the upper left, you see some equipment that sorts single sheets of fiber from containers. On this slide just before, you saw the mechanical screens that we use to separate fiber from containers. But as because it's never 100% accurate, we use an additional type of technology, this air classification, to do the last step in trying to get recover any fiber from the containers. One reason is we don't want the fiber contaminating the containers, and of course we don't want to lose the fiber into residue, so we would like to make sure that the fiber goes back into the fiber as much as possible in order to increase the yield in the facility. The second application where we use air classification is on separating fiber and light materials such as maybe plastic caps, etc., from broken glass. And you see that picture on the bottom right. Mostly to make sure that if the glass goes on to a glass beneficiation facility, that a large amount of the contamination is already been removed. Recover any fiber from the containers. One reason is we don't want the fiber contaminating the containers, and of course we don't want to lose the fiber into residue, so we would like to make sure that the fiber goes back into the fiber as much as possible in order to increase the yield in the facility. The second application where we use air classification is on separating fiber and light materials such as maybe plastic caps, etc., from broken glass. And you see that picture on the bottom right. Mostly to make sure that if the glass goes on to a glass beneficiation facility, that a large amount of the contamination is already been removed. The last step in the conventional excuse me, in the conventional sorting technology that I'm going to talk about is metal separation, and the first one would be straightforward magnetic separation. You see a picture of two overband magnets here. The picture on the next slide shows a drum magnet, and those are just two different types of technologies that we use. Again, it depends mostly on the volume of the facility on which of the two technologies we would use. Some of them are more expensive than others, so depending a little bit on, again, mostly the throughput, we would use one over the other. The next slide shows an example for an eddy current separator. This type of machine is used to sort aluminum cans from a MRF stream or container stream in a MRF. And the way it works is that aluminum cans, as the material is accelerated on a pretty fast moving belt, the one you see in the picture, it will kind of move from right to left along those ridges you see on the belt. And as the cans get to the head pulley of that conveyor, an eddy current force is induced into those cans, and it repels them away from the stream, and they jump across the gap to the far left in this picture. And so you can separate the aluminum cans from the rest of the stream. So that kind of covers the majority of mechanical or conventional sorting equipment that we use in the MRFs. And as I mentioned, the optical sorters would kind of go after any of these pieces of equipment that I just briefly discussed. So on the next slide, we'll start with the part on the optical sorting equipment. As far as our division MSS is concerned, just a very quick overview so you have a little bit of background. We've been around for quite a long time, coming up on 38 years pretty soon. So in the earlier years, we built and developed specialized metal detectors for all kinds of applications. But the first true optical sorting equipment came in 1989, and then as the years went along, we're probably now in our 6th generation of plastic sorting equipment that we use. And in parallel with the development and further manufacturing of plastic sorting systems, we developed all kinds of other technologies along the same line, all based on optical sorting and identification technology. In 1993 and 94, we built the first systems to sort ceramics and glass by color. In 1998, we introduced the first paper sorting system. And in 2006, one of our newer areas of where we use the optical sorters is electronic scrap. As a company, we have been part of the CP group since 2003, so it's been just a little bit over 9 years now that we've been with them. A little bit of background on how the optical sensing technology works that we use in MRF applications. In general, we use properties of the materials in an electromagnetic radiation spectrum between ultraviolet, visible, and the infrared wavelengths. So if you go from the very high energy short waves, the gamma rays, X-rays, all the way to the right where heat and radio waves are, we're actually really looking just at a very, very small spectrum on the magnetic radiation scale. And so the ultraviolet, visible, and infrared is what we would call or describe in the optical sorters that we manufacture for these applications that I will be talking about today. And mostly we would use the visible or the color identification and the infrared identification. The color identification works pretty much very similar to how your camera works. And in your camera, normally there's a chip in there that registers colors by different wavelengths, and in the camera it's normally red, green, and blue that are registered, and then depending on what absorption there is for each of those colors, a summarized or a final color is generated, and that will be the color that you actually then see. Now in the near infrared wavelengths, where we actually are able to tell different types of plastics and organic materials apart, it works quite similar. It's just not in a wavelength that the human eye can see, but we're still looking at for the material to absorb energy at different wavelengths, and depending on which wavelengths those absorption peaks and valleys are, we can tell what type of material is. As far as the molecules go, you see a little graph on this slide. What we do, we illuminate the material with reasonably high energy near infrared light, which is normally used or done using halogen lights, and then it activates or absorbs wavelengths in the bonds between the molecules, and those are very specific. So depending on what molecule you have, or in other words, what type of plastic or organic material you have, you will get different absorptions, and our sensors can measure that. Again, it works very similar to something that is red absorbing the green wavelengths, and you see red, and this just works in the near infrared where the human eye can't see it, but the absorption principle is still very much the same. Here's an example of such curves that we generate in our sensors. So you see different graphs for different plastics. In this particular case, there's nylon 6,6, PET, and polypropylene, and you can very easily see if you look at the curves of these different plastics. You use some reasonably fancy math to analyze those curves, and you can tell apart the different types of plastics quite easily. And this is the type of technology and algorithms that we use to tell them apart. Now, as far as an actual machine is concerned, what we do is for especially the plastic sorting and the paper sorting, this normally happens on a very fast moving conveyor. Now, in this picture, it runs from the upper left to the bottom right. And what we do is with the near infrared and the color sensor, we actually scan the complete width of this conveyor. You see the little beige yellow bar across that kind of represents the halogen lights. So they illuminate a band across the belt, which is shown in red. And then we use our scanning mechanism to scan across the width in very fast intervals. And then we have our hardware and software that actually analyze those signals and are able to identify the different types of materials going over or through the area, through the scanning area, and they can then be sorted according to type and color. Here's a picture of those halogen lights. You see on the on the right, you see those the lights behind a protective glass so that we don't break the, by accident might break the glass. You also see lenses on the left. That's kind of where the light is then bundled and sent to the detectors. So in other words, the light is emitted by the halogen lights onto the conveyor belt and is then reflected more or less straight into those lenses, where then the analysis of the spectrometer is done. So this is a little more shown in a diagram of what types of arrangements we can have. This mostly depends on the application. For example, if we're just sorting types of plastics and maybe fiber or remove contaminants from fiber, we would use, as I just described on the slide before, a reflective system. So we have light sources or a light source shining down on the material, and the light is reflected off the material and goes into a sensor array. In certain other applications, for example, our glass sorting equipment, we actually measure the properties of the material in transmission. So we're actually looking through the glass or through the material in this particular case. So the light source and the sensor array are on opposite sides of the material. And then we have a system where we actually do somewhat both at the same time, where we have a light source with a reflector behind the material, so that if the material is opaque, for example, an HDP bottle, the light is simply reflected. If the bottle is transparent, the light will go through the bottle and be reflected and go through the bottle again before it goes into the sensor array. We mostly use that kind of application or arrangement when we sort PET bottles by color, because this arrangement allows us to see really very small differences between different colors. Now, if we take this a step further, again, using one of the different types of arrangements of the near-infrared and the color sensor, we can also add other types of sensors in case we need more information to sort more or different materials out of the stream. For example, we can add a metal detector that we can build into the conveyor belt. So we can, for example, if you had a magnet or an eddy current separator that I described earlier, upstream of the optical sorter, but because those metal sorting devices, again, don't work perfectly every time, there might still be some residual metals in there, and we would like to sort it out with the optical sorter, then we can do that using an additional metal detector. Furthermore, as far as a mechanical arrangement of what we can do, once the material is identified, then we would like to sort it out. We normally use air jets, very high pressure air jets, to do that. So as the material comes off the end of the belt, immediately afterwards there are a series of air jets that then direct the material that was selected directly into different types of output chutes or bins. And in this particular slide, you can see we offer an arrangement where we can generate 3 outputs or up to 3 outputs from one input stream, with you see the eject number 1, the green bottles being ejected downward, the teak colored bottles being ejected upward, and whatever is left, the orange ones, would just kind of fall through. So I've covered basically how the technology works, from the spectrometer to the arrangement with the halogen lamps, different arrangements of sensors, combination of sensors. So basically, or essentially, all our optical sorters function very similar and are kind of a combination or different arrangements of what you just saw. So now I'm going to go through some different types of machinery that we use for different applications in MRFs and or recycling facilities. And so you see some examples of machinery installed, and also what we use the different types of machineries for. So for example, the first one that I'll show you a few pictures is our Aladdin unit, which we use in material facility, in MRFs, and also in plastics recycler facilities. So in MRFs, if we use it to most of the times we use it to sort PET. If the volume is high enough, we'll use it to sort HDPE natural and HDPE colored. In some facilities that have a high enough volume, we'll sort number 3 through 7 plastics and beverage cartons. At plastics recycling facilities, we'll use the same optical sorter, the Aladdin, to sort PET by color or HDPE by color, and we'll try to remove as much contaminants out of the stream as possible. So if you're a PET recycler, you would definitely want to remove PVC and some of the newer packaging plastics that you may have heard of, like PLA or PETG. Just for a little bit more further visualization in how we install some of these optical sorters in facilities, there's a few pictures now, one after the other, to show you different arrangements. For example, here's to handle a very high throughput. We may have to put 2 of them side by side, like shown in this picture. If we do multiple sorts in series, and we need more than just one optical sorter, so we can put them in line. If the space is tight, we might actually use it, orient them at a 90-degree angle, or kind of L shape, if you will, like shown in this picture. And last but not least, if you have quite a bit of height but not very much length in your building, we can actually stack them on top of each other in kind of a Z or S configuration, where the material goes over the first one on top, falls down, and kind of runs backwards underneath into the second one, up into the second optical sorter located right underneath. The next type of machine that I would like to show you some examples of is what we call our Fibre Sorter or Sapphire unit. It's kind of a lower cost version of the Aladdin that you just saw earlier. It doesn't sort by color, it only sorts by type of material. But essentially it's still a fast-moving conveyor with a sensor housing sitting on top and a catcher hood at the very end. Now you can see here's an arrangement rendering of 2 Sapphire units in series. You can see those can be quite compact, as we can stack them more or less one after the other. In MRFs, we use the Sapphires mostly to sort HDPE and number 3 through 7 plastics. We also use them to sort beverage cartons, and if we put those type of optical sorters for just sorting by type of material on a, for example, on a fiber line, we can actually remove non-paper contaminants such as plastics and textiles, etc. We also use these machines in what we would call dirtier applications, like municipal solid waste, residue-derived fuel, commercial, industrial, C&D, where we can extract fiber, where we can extract plastics, or where we can remove PVC from the stream if that's required. Next slide. Now the Fibre Sorter, again, is very similar to the Sapphire, just has slightly different filter sets and a slightly different spectrometer inside. We use it to sort, to clean up fiber streams in MRFs, where we can remove the non-paper contaminants, we can remove the brown OCC if we need to. We can use it at paper recyclers, again, to remove paper contaminants, and we also use it in C&D applications to sort out wood. Our multi-wave unit is a multi-sensor machine. We have a total of up to 5 different sensors in this type of machine, and we use it mostly to sort large volumes of fiber. We have some patented technology to run those conveyors at speeds at up to 1,200 feet per minute, so very, very fast, which allows us to go process very high volumes. And so obviously that machinery would, really only apply to high volume MRFs. But what we do, we can sort all kinds of materials with these machines: newspaper, mixed paper, magazines, color paper, brown cardboard, printed cardboard, and also, again, the contaminants such as plastics, metals, etc. We have our paper sort unit, which is a specialized unit that we use almost exclusively for sorting office paper type materials. So if we use, we have several installed in some commercial facilities, where after removing the cardboard, which is normally a very high percentage in the stream, there's mixed paper, but still a very high percentage of office paper and white paper in there. So we can use this type of optical sorter to extract white paper from the mix, or sort away mixed paper from the white or predominantly white stream. Going from plastics and paper now to the glass sorting, again, we use these machines in MRFs or in glass beneficiation plants. Mostly, and we use them basically for 2 types of sorting. One of them is to remove contaminants such as ceramics, stones, porcelain, or short CSP, and metals. And then we, of course, also use them to sort the glass by color. Now, in the US, it mostly depends on geographically where you are, if you really need to sort all 3 colors, green, amber, and flint, or if you just make a flint and a what is called a gramber mix. And here's just some examples of some of these pieces of, that we're trying to sort out. You see on the upper left a small piece of ceramic that we're trying to sort from the glass. You see different colors, blue and green and olive, that all have to be sorted. Normally, or in most applications, I would say we're only sorting flint from gramber, but in certain facilities we also sort the green from the amber as well. One of the things that's common between all our machinery is the user interface. So we try to strive for it to be very user-friendly. You don't have to do any calculations or type in any numbers. You really only use your intuition to program these machines. So, for example, on the upper left, you see the main screen that shows that the machine is running and some of the parameters that we monitor while running. At the bottom left, you see a screen called Sort Configuration, which allows you to select different recipes. In most machines, we have up to 8 different recipes. So if you happen to have a material with a different input composition, or if you'd like to sort something differently on different days for one reason or another, then you can just switch between different sort configurations very easily. On the bottom right, you see the setup of the different sort configurations. So you see the list of all the different materials that have been programmed into the machine, and then in your recipe or in your sort configuration, you simply select the ones that you would like to sort out. And so behind each of the sort configurations or each recipe is one full set of configurations where you can select which materials should be sorted and which ones should stay in the stream. We also have, obviously, with the computer technology being more and more advanced, we have complete remote access to our machines. So just like we're doing a webinar here, we can access our machinery through either an analog modem or the Ethernet. And so this allows us to troubleshoot and assist the customers if there happen to be any issues with the machine, or if they would like to train a new material, etc. Other applications, just to kind of round out at the types of machinery that we make that are not necessarily used in MRFs. Again, on the plastics recyclers, we have machinery to sort bottles and flakes by color and by type. And as I mentioned earlier, one of our newer fields or in our newer areas is sorting of electronic scrap. So these are obviously completely different facilities from a single stream or just a commingled MRF, but I just wanted to list that up to round out the types of optical sorters that we manufacture. So I hope I was able to give you a quick overview over the first part. Talked a little bit about the mechanical, more traditional types of separation equipment that are used in MRFs. Then gave you a quick overview on the optical sorting technology and the background, how it works exactly. I hope I didn't go too much into details there. And then showed the arrangements, the different types of sensors that we use for the different types of applications. And I think that's the end of my presentation, and I'll give it over back to Jack. Thank you.
Well, thank you, Felix. That was a very good presentation. There are two related questions I'd like to ask before we go on to the next presenter. Felix, how small a piece of plastic can be detected? Is it bottle size, or can you have resolution down to much smaller than that?
It depends on the type of machine that we use. For example, in MRFs, we normally don't have to see particles much smaller than about 2 inches, maybe 1.5 inches, because those are normally screened out as fines. So in applications for MRFs, the resolution of the machines are higher, obviously, but in MRFs we normally have to see particles down to about 1.5 or 2 inches. Now in applications where the particles are a lot smaller, like electronic scrap or plastics recycling facilities where we're sorting granulates or pellets or flakes, then in those instances, we have to see much smaller particles. And for the sorting of by type of material, where we use the near-infrared spectroscopy, we can probably go down safely to about 3/8 of an inch. If we're only sorting by color, the color cameras are very high resolution these days, so we can probably go down to under, probably a 1/16 or even a 32nd of an inch there.
Okay, and the related question is, how much density can be detected on a conveyor? And I believe that means can the material be only a single layer thick, or is there some capability of doing, stacked on top of one another to a certain extent?
Yeah, it may also relate to items that might be heavier. For example, in the MRFs, we mostly see it with, for example, bottles that are filled with liquids. And those are, the bottles that are empty, they're obviously quite light, have a fairly large surface area. So when you hit them with the high pressure air jets, those move very, very easily. But as you start, for some reason they might have, liquids in them still. If they're, getting too heavy, then the sensor will see them, but the air jets are not going to be strong enough to sort them out. So in general, I mean, if I'm not quite sure exactly on the the pounds per square inch that we can move, but if you take your regular single serve PET bottle, like a 60 to 12 or 16 ounce, if it's more than a third full, we will probably not be able to sort it out. You could obviously have air jets that are stronger, or put up the pressure, or put more air jets. But then if you do that, you're always the more air you use, or the stronger you blast, you always ask for cross-contamination going with the material that you're trying to sort out. So there's a little bit of a balance to be found of how much you'd like to blast on a certain type of plastic or item, so that if you made it very sensitive, you could probably sort out a bottle that's half full of water, but you're going to have other items with it because you're blasting so hard.
Okay, thank you. And we'll have some more questions toward the end. So thanks again, Felix, for your fine presentation. Now we're going to move on to Matt Kugel, from Kugel's Recycling in Hamburg, Pennsylvania. Matthew Kubu has over 15 years of experience in the recycling industry. Matt was recently recognized by the East Penn Business Journal as one of the top 30 under 40 in business. Matthew has held various roles within the company, which has allowed him to gain extensive knowledge of the industry. He currently serves as Vice President and Chief Operating Officer. His expertise encompasses facility layout, design, operation, and maintenance of equipment, production quality and quantity, material procurement, commodity sales, and marketing. Matthew resides in Greenwigsville, Pennsylvania with his wife Jill and young son Jackson. Let's turn it over to Matt Kubu.
Good afternoon. Thank you, Wayne, and thanks, Jack, for the opportunity to present. I'm going to just take a couple minutes and do an introduction of our company and then talk a little bit about the decision-making process for us when we decided to employ the optical technology and what brought us to that, and some of the things that we've learned through that process, as well as in the process of actually operating that equipment. I'm COO of Kubu's Recycling, the third generation of this family business. We've been in business for almost 70 years. We work with a vast array of different customers, ranging from industrial, institutional, and municipal, and we customize programs that cater to our customers' needs, depending on their particular situation. We are currently operating 2 locations, and at our first location, which is a full-service material recovery facility out of Hamburg, Pennsylvania, we're sorting and separating paper, plastic, glass, and metal material. And our second facility in Auburn, Pennsylvania, we do the downsizing and manufacturing of different plastics material, from downsizing and washing plastic to the manufacturing of reprocessed pellet and the production of lumber material. We feel that some of the differences that CRI brings to the table is that we believe in our mission and practice this in our everyday operation. Our companies were founded on the principle of reusing and recycling, and we employ that philosophy in our business. Over 25% of our facility's energy is provided by solar panels. We also produce an alternative fuel material that keeps material that was bound for the landfill out of the landfill and helps save our natural resources by using this as an industrial fueling, saving oil and natural gas. We also produce some finished products, some of which I just spoke about, as well as the glass aggregate, which is used in different construction applications. And one of the things that we've really taken a lot of pride in is helping our customers along in their path and their journey to reducing their waste stream and increasing the material that they can recycle. Throughout our history of almost 70 years until today, we maintain true to our values and principles of hard work, determination, consistency, and integrity. Kubu's Recycling was founded by my grandfather and started as a civic duty around the World War II era. And we try to fulfill those obligations today to our employees, our customers, our community, and the environment. Today, in our current situation, we are able to provide a multitude of different services and options, carefully considering the material challenges, operational challenges, and transportation costs to provide our customers with the best option available. Now, I just want to go through some of the factors of what we looked at when we were looking into optical sorting technology, and some of the things that I think would be important to consider. When we sat back and looked at what was the next phase for our company, as we've seen the single-serve bottles increasing, the weight of the PET decreasing, the need to put more people on the line to sort less volume per person per hour, we wanted to look at what's the next step. And just like any other production facility, there's a need to increase production and either maintain, if not increase, quality at the same time. So because of that, we wanted to look at a way that we could adopt those philosophies, and we look towards optical sorting technology. In addition to the actual sorting process, also the labor force for these sorting jobs is generally a lower wage and high volume amount of labor. So combining those things together, the training is very difficult. And this feedstock is to some degree adjusting as the economies and the different materials change. Next slide, please. So some of the things that we had found as hurdles to our optical sorting and some of our considerations was the large investment up front, not only of the optical sorting equipment, but also the processing equipment, conveyors previous to it, and things, air compressors and things of that nature. Also the discipline that would be required to ensure that the equipment was maintained properly and that the maintenance staff was trained and qualified in order to fix this equipment to ensure that we could keep the facility, that piece of equipment, operating. We also wanted to consider the additional operating costs, excluding the labor, such as the additional capital initially, the maintenance of the additional conveyors, the air compressors, and ensuring that the material was prepared properly to go into the optical sorter. And one of the challenges that we needed to seriously consider, and I think needs to be thought of, is that this piece of equipment is sorting all of the plastic coming through the entire line. So the entire line is dependent on that piece of equipment to ensure that you have uptime, being if the equipment previous to or after the optical sorting equipment is working. If the optical sorter is not working, the line can't run. Next slide, please. With looking through some of the different optical sorting companies and looking at the technology, we felt strongly that we were able to meet a lot of these challenges with this optical sorting equipment, which allowed us the ability to increase our facility or line production, at the same time improving the quality. And this was able to be done by increasing the amount of material that we were sorting, reducing the amount of man sorters or laborers, and providing their job as more of a quality control job. So after the materials were sorted out, these large volumes of single serve PET bottles and those plastics that are continuing to be reduced in weight and increased in volume or amount, they're basically looking at the material as it goes across the belt and seeing if something is in there that should not be and removing that material, rather than picking every single piece as it comes across in front of them. Also allowing us to reduce the amount of low-wage sorting positions and increase the wage on some of the higher trained, although it is still a sorting job, we could pay a little bit better and give them a little bit better training because they're more of a quality control position and we don't need the amount of sorters on that line to pick a higher volume of material. And the production is less dependent on a large labor staff coming in every day. So if a person or two missed, it didn't significantly or drastically reduce the production for that particular line or that day. One of the other things that we had to strongly consider was the ability to change settings and adapt to the material stream. As we recognized from the past, there had been changes in marketing of a particular material and the packaging of that material. How are we able to adapt and change to that to ensure that the equipment can sort that material out? Before going into purchasing an optical sorting equipment, I feel that there's several things that are very important to ensure that you're moving forward in the right direction. First of which is your facility size and the amount of volume that you have, to see if optical sorting is really a fit for your facility or not. The other is to ensure that you either have access or have trained maintenance staff, because this equipment, although there may be technical support provided, in order to ensure that it's maintained properly, to replace parts, to keep the other ancillary equipment going, the maintenance staff needs to be able to troubleshoot and be able to understand the operation of the equipment. And last but not least, when you're choosing an optical sorting equipment company, I think it's extremely important to consider several things, because even if you're meeting all of the needs on your side, the optical sorting company or the company manufacturing the equipment needs to stand behind you, not only initially at the design and implementation phase, but also through the entire phase of the operation of your facility. So if the equipment provider has a solid industry history, do they have background to support in the industry? And will the company be able to provide remote assistance for your staff to troubleshoot, look in the program new materials, or train staff when you have a new maintenance person or someone heading up that particular area? And will the equipment sort all the materials that need to be sorted, and is it flexible for the future? Will the startup include training for the operational and maintenance staff? And if the company will support afterwards, be it if it's dialing in to help troubleshoot a problem, or providing a part or technical assistance on how to replace that part. We had moved forward with considering a vast amount of different companies for optical sorting, and had ended up going with MSS. And just as a little testimony, we were very happy with the results that we provided us from the design phase all the way through till today. If we have an issue or a problem we need to troubleshoot, we've received great support. So that's just a little background of our company and our experiences with the optical sorting technology, which we're very happy that we've moved in that direction. I think it's definitely a benefit to our entire line and our operation. And that pretty much wraps up the information I have and my presentation.
Well, thank you very much, Matt. That was very enlightening. There's a couple questions for you, and some more for Felix. Matt, you had mentioned the importance of maintenance and cleaning of the conveyor equipment, and I assume that also means the optical sensors. Could you briefly describe what sort of maintenance or cleaning that you have to do for the optical sensors?
Sure, definitely. Basically, one of the things that's very important, as Felix had shown in his presentation, the light is being put down onto the material and then reflected back into the sensors. Because the nature of our industry, some of the material is wet, some of it has some different types of debris, maybe fine materials on there, and when you're blowing that around with an airburst, that material is scattered. So it's very important that the sensor and the light itself is kept clean to ensure that you're getting the correct results. Because as it's looking through the sensor and the light, it's measuring what type of material it is. So on a very regular basis, for us about twice a day, we're cleaning off the sensors, cleaning the light, making sure that the air nozzles are free from debris, making sure that all the air nozzles are firing and all the sensors are working properly. It doesn't take an extreme amount of time, but it is very important to the operation of the process. There's also sort of an airstream that carries, at least in our machine, an airstream that carries the pass-through or the carryover material, and we need to make sure that any debris that may inflict with that airstream are cleared away, and that area is clear as well.
Okay, good. Felix, is there anything that you would want to add to maintenance and cleaning of optical sensors?
In general, I would just say that as long as you keep the areas of where the sensing actually happens, so that, as Matt mentioned, where the lights are and where the windows are, if you will, of where the sensors are behind those windows, as long as you keep those clean, The machines themselves are really just mechanical pieces of equipment that you have to, keep maintained, because essentially it's just a fast-moving conveyor with, a very specialized computer and sensor on top. But so as long as you keep the machinery clean, and again, in some machines it's a little easier. In other machines, for example, the glass machines, those take a little more time, just mostly because the material tends to be dirtier. So as long as you keep them clean on a regular basis, as Matt said, if the material is dry, normally once a shift is plenty. If the material gets very wet and dirty, you may have to clean maybe once every 1 or 2 hours. So as long as you do that, the machines will function just fine.
Okay, thank you, Felix. Matt, you had mentioned single serve bottles, and I think you mentioned that they were PET, plastic, like water bottles and so forth. Is there also a single serve glass container that you would put into that general definition?
Well, what I was referring to in particular on the optical sorter for the plastic was the single serve and generally the PET water bottle. As we, over a period of years, we've seen that increase significantly. Generally with the single serve glass, and Felix can correct me if I'm wrong, but generally with any type of glass product, it's broken before it goes into the optical sorter for the glass optical sorter. So that would not create as much of an issue. Although I think in the future, or at least in the near future, we're just going to see the increase of all types of single serve products, just because of how the market is being driven.
Okay, thank you, Matt. Felix, what problems can occur with clear plastics or really dark or black plastics as far as being able to recognize them with this type of equipment?
Yeah, with the really clear items, or again mostly bottles or maybe some PET thermoforms or polystyrene thermoforms, the newer technology that is around, and that's not only ours, but it's improved significantly over the last few years. So we're really able to do quite well on seeing the highly transparent plastics, as objects, and then sort them into the different types of plastics. The black plastics are still an issue that pretty much all manufacturers of this type of equipment are still trying to work on. We can sort out the black items from all the other items, but we cannot tell them apart from each other. So if you have, let's say, black thermoforms or black plastics in your container stream, we can sort those out. But whether it's a black polystyrene or a black PET thermoform, the machine can't tell the difference.
Okay, thanks, Felix. One more question for Matt. Matt, you'd indicated 25% of your energy requirements come from solar panels, and the question is, does any of that energy go directly to powering large equipment like conveyor equipment, or does it more go toward general lighting or uses like that may not have such a large current draw?
No, it actually goes directly into powering our large equipment. One of the processes that's powered by that the solar array that we have on our roof is the commingled sortation line and the optical sorter that we're using.
Oh, okay, good. That's very good. Okay, I think that's all the questions. So I wish to thank Felix and Matthew for your generous use of your time. Oh, wait a minute, we have one more quick question that came in. do bottles/cans compose more than one material? For example, an HDPE bottle with a polypropylene lid. How well do these mixed plastics go through the optical sorting equipment? Maybe first Felix.
Well, in general, from a processing standpoint, if there's whether there's an HDPE or a polypropylene cap on a PET bottle or a polypro cap on an HDPE bottle, the recyclers downstream don't really mind if there's that kind of contamination in it. From a sensing or identification standpoint, the sensors will be able to see that there is a cap of a different material or an area of a different material on this bottle, and it's really up to the consumer, up to the operator, whether you would like to sort that out. For example, in some PET facilities where there might still be some caps out of aluminum, the aluminum could obviously, if it's there in higher volumes, it might possibly damage some of the granulation equipment further downstream, so they would like to sort it out. So we use our sensors to identify the caps on the large bottle, and we tell it that even if you see just a very small amount of metal or contaminant material on a PET bottle, make sure you kick it out so that we don't have any contamination into the clear PET. But those were probably more extreme examples. In MRFs and in most applications, if there's only a small amount of contaminant that is connected or not liberated from the material, the software will ignore it, or the operators normally say ignore this, this cap or this small area of the other material versus the main material, and just let it go through.
Okay, Matt, anything you'd want to add to that?
I think maybe to follow behind that, it does very well on materials that have those caps or a small amount of other contamination on it. As you're setting up the machine, basically you're taking sort of a picture or a profile of these different types of material, and then you're able to make decisions on how many pixels you want to fire on, or so you're able to basically customize it not only by the type of material but the amount of contamination. So once you go through and I could say train the equipment, it does very well on that material.
You could also compare it, for example, a more daily occurrence would be if you had a white sweater and you drop some spaghetti sauce on it, and so you run that through an optical sorter, and you basically qualify of how big the spot needs to be before you throw it out. So you can kind of look at it that way. It's just looking at different materials versus different colors or wrong colors, but it's kind of the same principle. You can make it more or less sensitive to certain materials.
Yeah, my wife can spot spaghetti sauce in my shirts a mile away. Well, that's a great webinar today, Felix and Matt. Thank you very much, and thanks to the audience for their good questions. And Wayne, thank you for being in the background and running everything for us today. Thanks for attending this Technology Tuesday webinar. And we'll send you information about our next one, currently planned for December, on alternate uses for gypsum drywall material. Thanks again, and have a good day.